Okay, I will start the lecture right now. Please take out your notes, right? Okay, so remember for this subject, we will have 7 chapters. This is the second chapter, which is the probability. Okay, so I will spend about 2 weeks to complete this chapter. Okay, so I divide it into 2. One is probability, and the second one is probability distribution. Alright? Okay, so, okay, is that okay to start? Can? Good. All right. So let me introduce. Okay. So before we talk about the probability, can you look at this picture? Right. So you see, there is the range. Okay. It will between 0 to what? 0 to 1. Okay. So if at the meter, okay, it is 0.5, right? We call it as 50-50%, right? What does that mean? Okay, so in terms of probability, we say that it is evenly distributed, right? So 50-50%. So between 0 to 0.5, we say that it is unlikely to be happen. Unlikely, right? So how about the probability is set to be 0? Means that it is impossible. Okay, right? So how about between 0.5 to 1? It is likely to be happen, right? So somewhere within that, we say that likely to be happen, right? So how about if the probability is 100% or 1? Okay, we say that it is very sure 100%. Okay, 100%. Okay, this is the indicator we use it to describe probability. Okay, so we normally use 0 to 1. Okay, so that is why in this case, what is probability? By definition, probability is the likelihood or the chance that a particular event outcome would happen. Alright? So it must happen from a random experiment. Okay, so I will explain these terms one by one later. Okay, these are the things that you must know, right? So now, what is the measurements of probability? It can be measured between 1 to 0. Okay? 1 to 0. 0 to 1. Okay? From this figure. Okay? 0 to 1. Okay? So it can be expressed in percentage. Okay? Proportion. Alright? So what is meant by a probability of 1? Okay? It is 100% sure. Okay, what is about the probability is 0, impossible. Okay, so this is the measurements of the probability. All right, can understand? Okay, right. Okay, so there are few terms that you must know before we talk about the calculation of the probability. Let's us have a look one by one. Okay, the first one. Okay, the probability. Okay, we must know what is the meanings of random experiment, sample space outcome, and the events. Okay, then only we discuss about the formula to calculate the probability. Okay, so first thing, let us have a look. What is called as random experiment? Okay, random experiment. Okay, so for example, okay, this is the simplest example that we can perform. Okay, random experiment. Okay, for example, when you take out a coin and then flip it. Okay, whenever you're flipping a coin, you are performing the experiment. Understand? Okay, when you performing, okay, when you take out a coin and then flipping it, okay, so actually you are performing a random experiment. Okay, random experiment. Why? Because look at this. Okay, what is the possible outcome from here? Possible outcome. You could get the outcome, the result give you what? H is indicate head. T is indicate tail. Okay, so 2 possible results only. Okay, if calculate its probability, later you know that it is 50-50%. Okay, that is called probability. Alright, so how about another example? Okay, so this is also an example for the random experiment. Okay, in this case, you roll. Okay, rolling a dice. Okay, So it's called as random experiment. In this case, what is the possible outcome? What is the possible outcome? It could be what? It could be either, can it be 0? Cannot. Okay, what is the possible outcome? 1, 2, 3, 4, 5, and 6. Okay, later we will talk about this outcome later. Okay, right? So this is also an example for the random experiment. Okay, so by definition, what is meant by random experiment? Okay, random experiment is the experiment that can result different outcome. Okay, different outcome, even though it is repeated the same manner every time. Okay, you try if you said that if you perform an experiment and then the outcome always give you the same, is that still called random experiment? No, it must be different outcome. Then it is called as random experiment. All right. So what is meant by random experiment? For example, you have the input, go through a system. This system is subjected to affected by the noise variable. What is meant by noise variable? It is not means by the sound or noise. Okay, it is means that the control variable that we can't predict. Okay, noise variable. Okay, and it can be control variable that it is known that we can control. Okay, and then based on this we should have outcome, different outcome. Then only it is called as random experiment. All right. Okay, so this is also another random example. Okay, random experiment example. For example, during a QC checking. So imagine that in a production line, okay, so you are doing the QC checking. So in this figure, they ask you to imagine that you are positioned at the end of the assembly line. Okay, so you are required to do a quick check. Okay, so to take out a cell phone and then turn on and off. Okay, so each time you remove a cell phone and turn it on and off, actually you are conducting a random experiment. Okay, because the outcome will give you what? Good or defect. Correct? Okay, so this may be the outcome. Okay, each time you pick up a phone is a trial, randomly choose. Okay, and with a result that can be marked as a good phone or bad phone. Okay, the result of each experiment is therefore called an outcome. Okay, understand? Okay, so this is the overall idea for an experiment, random experiment, for the random experiment. Okay, all right? Okay, understand? Okay, so this is related to the random experiment. Okay, the next one. How about the sample space? What is meant by the sample space? Okay, let's figure out. Okay, a sample space is the set of all possible outcomes of a random experiment. We use S to represent sample space. Okay, so what does that mean? Okay, for example, okay, based on this random experiment, based on this experiment again, okay, whenever you flip a coin, what are the possible outcomes? Okay, just now I already mentioned it could be either head or tail. Okay, cannot be others. Okay, hence, what is the sample space? So the only possible outcome, it could be head and tail only. Hence, this is called as sample space. Understand? Okay, all possible outcomes. Okay, so that is called sample space. Understand? Okay, then how about this example again? Okay, back to this example. Okay, so what is the sample space for this? Again, must be there are 6, 1, 2, 3, 4, 5, and 6. Okay, this is called a sample space. Consists of 6. Okay, that is 1 until 6. Okay, these are called sample space. All right, can understand? Can? Okay, so let's move to the next one. Okay, the events. Okay, so events is the sets of the sample space from a random experiment. If you have studied the Venn diagram, okay, it is like this. Okay, so you can say that subset. Okay, it is subset. What is mean by subset? What is mean by subset? This is sample space. This is E. E is subset with S. Okay, so subset is of the sample space of a random experiment. Event is denoted by E. Okay, so the number of events always less than or equals to the number of sample space. Okay, so that is the criteria of the events, right? So in Venn diagram, it can also presented in this form. Okay, we know that the E is subset with S, right? Okay, let's move to this example again, and then we figure out what is the meanings of these events, right? Okay. For example, okay, did I give any example? Okay, can. Okay, let us have a look for this. Just now we know that through this example, the sample space is equals to 1, 2, 3, 4, 5, and 6. Okay, we can say that the number of the sample space is equals to 6. There are 6, right? Okay, now let's say I want to define the events. Okay, these events, I want the number, okay, which is odd number only. Okay, so what is the elements that fulfill this criteria? 1, 3, and 5. Eh? I cannot choose 7 because it's outside the number of the sample space. Okay, hence you will notice that the number of events is now equals to 3. Okay, so what is the meanings? You will observe that the E is subset with the sample space, correct? Then the number of the events is always less than or equals to the number of sample space. Understand? Okay, so this is called events. Okay? Okay? Alright, let's move on to this. Of course, the events can be presented in the Venn diagram. I will not go through this, but just for the revision, what is the meanings for this symbol? Union. Okay, what is the symbol of this? What is this? Intersection. Okay, so what is the meanings by this? Not C, or we say that complements of C. Okay, it's not C. Okay, so the events always can be related with the Venn diagram. So that is why we have the events relation in this few slide. Okay, but I will not going to talk about this. Okay, now let us move to the counting sample point. Okay, there are two types, either permutation and combination. Okay, permutation and combination. Okay, so for example, okay, so what is mean by this? Okay, permutation and combination. Alright, suppose that a sample of 2 is selected from 4 named as A, B, C, D. Okay, so in this case, let's say every time this is the elements that I have, A, B, C, D, named as A, B, C, D. Every time I need to pick 2 out of these 4. So what is the arrangement it could be? Okay, so it could be have 6 different choices. Okay, so for example, I can say that I can get A, B at the same time. It could possible, right? Every time you choose 2, it could be A and B. Okay, it could be sometime I will get A, C. Correct? Okay, sometime I will get A, D. Okay, I also can get B, C, okay, B, D, and also the last one is C, D. Okay, I could get 6 possible different combination of it. Alright, but in some of the cases, I also can get 12 different combination, 12 different possible choices if it is named as this, you see. Okay, in this case, A first, followed by B. The first time you pick must be A. Okay, we consider the sequence of it. So must be A first, followed by B. Okay, hence the arrangement now will be A, B, okay, A, C, okay, C, A, okay, then C, A, okay, so we will have A, D, okay, D, A, okay, we will have B, C, okay, okay, BC followed by CB, okay, followed by BD, okay, it could be DB, okay, interchange the position, okay, so now we have 1, 2, 3, 4, 5, 6. Okay, DB, then we have CD, we have DC, and then we have BA. Alright, so we have altogether 12 of it. Okay, so in this case, we consider the order. Okay, it must be first A, then the second one B. So we have take into the order. Okay, so that is the meanings of that. Okay. Alright, is that okay for this one? Okay, so let us have a look with the combination rule first. Okay, I will not focus on this because your calculator already equipped with this function. Right? Okay, can you find your calculator? Are you able to find this function, combination? Can you check your calculator now? Okay, are you able to find this combination? And choose a combination. Cannot. Got enough. Okay, this is important because it is related to the binomial later. Okay, so are you able to find this function in your calculator? Can you see this? Combination is referred to CP is referred to permutation. Is that okay? Are you able to find it? Yes, right. So let us have a look, go through to the fundamental of this first. Of course, let us have a look for the formula. Okay, so formula, okay, combination N choose R, okay, is equals to, what is the formula? What is the symbol of this? What is mean by this? What is this called? And what is the meanings of this? This is called factorial. Okay, factorial. So let us do the revision. What is the meanings of this first? Can you tell me that? Okay, what is 1 factorial? 1, okay. Are you able to find the factorial using a calculator? Can yes, okay. How about 2 factorial? 2 factorial is equals to 2 times 1 equals to 2. Okay, 3 factorial, this is equals to 3 times 2 times 1 is equals to 6. Okay, so that is the meanings. How about 0 factorial? 0 factorial also equals to 1. Okay, so this is the special case of the factorial. So 0 factorial, it is equals to 1. Okay, right now, okay, let us have a look for this example. Okay, okay, let us try this. Okay, if R is equals to 2, there are 3 combinations, namely A, B, AC, and BC. What is meant by this? Let us apply this formula and try to calculate the answer. Okay, so in this case, we want to have, okay, so let us have a look here. Okay, so now we need to perform F is equals to 3. 3 choose 2. Can you use your calculator to find out the answer? Okay, if we apply, okay, the formula, it should be like this: 3 factorial, okay, divided by R. R is 2 factorial. Then n minus R is equals to 1 factorial. Okay, so in this case, you should get the answer 3 times 2 times 1. 2 factorial is 2 times 1. Okay, 1 factorial is 1. Hence, what is the answer? You should have 3. Okay, you should have 3. This is how you apply the formula. Okay, Ken? Are you able to calculate the answer using calculator? Okay, can you try to do it right now? Okay, use your calculator to find out. Okay, combination 3 choose 2. Okay, 3 choose 2. You should get the answer which is equals to 3. Okay, you should get the answer which is equals to 3. Okay? Alright, understand? Okay, let's see another example. Okay, imagine that now, okay, you at a casino, okay, so you want to know how many different possible, okay, ways to win 5 cards, okay, you want to choose 5 cards from 52. How many different combinations? So, combination, the order is not important in this case, so we use combination. Okay, combination, if you apply the formula, okay, 25 choose 5. Can you calculate for me what is the answer? Okay, if we apply to the formula, we should write in this case 52 factorial divided by 5 factorial times 52 minus 5. Sorry, here is 52. Okay, so 52 choose 5. Okay, so 52 minus 5 factorial. So in this case means that this is 52 factorial divided by 5 factorial, then divided by 47 factorial. Okay, in this case, you should get the answer 2598960. Okay. Okay, so in this slide, I show you how you can check your answer using Excel. Okay, I will not show you first. I will show you during the tutorial. We can always check our answer using Excel. That is why I show you the function of this. Okay, we have to use equals combine. Okay, combine. Combine, use this function, use this formula, combine and choose R. Okay, 52 choose 5. Okay, you should get the same answer. Okay, use this function, combine. Okay. Alright, Ken, so far okay? Ken? Alright. Okay, I will move to the next example. Okay, So let's see another example. We have to apply the combination rules. Okay, a circuit board has 8 locations. Okay, which in a component can be placed. If 5 identical components are to be placed on board, how many different designs are possible? Okay, in this case, okay, assume that the order of the component is not important. Hence, in this case, combination rules is applied. Okay, so in this case, very simple. We want to use combination. In this case, there are 8 locations. Okay, so we can place 5. So 8 choose 5. Okay, so in this case, if we apply the formula 8 factorial divided by 5 factorial divided by 3 factorial. Okay, so the answer you get, there are 56 possible design that you can get from here. Okay, so of course in Excel you can use equals to combine. Okay, so 8 choose 5, you should get the answer which is equals to 56 as well. Okay. Okay, let's move to the next example. Okay, you see this then? Okay, so I write in this feels like divided into different parts of the solution. However, I just write the solution in one page here. Alright, so for example, in this case, okay, a bin of 50 parts contains 3 defectives and 47 which are the good one. Okay, a sample of 6 parts is selected from the 50 without replacement. Okay, how many different samples of size 6 are there that contains exactly 2 defective parts? Okay, how to solve it? Okay, so before that, let us look at this. So imagine that now, altogether, we have 50 parts. Okay, so we know that, okay, we already know that out of this, okay, 3 are defective. Okay, 3 are defective. Okay, and we know that, okay, the others, okay, 47 are the good one. Okay, then every time, okay, we do the selection, we will choose how many of it? 1, 2, 3, 4, 5, 6. Okay, every time you choose a sample of 6. Okay, we want to know that how many different samples of size 6 are there contains exactly 2 defects. Okay, exactly 2 defective parts. Okay, so in this case, 2 must be D. Understand? Okay, and that is the meaning. All others must be the good one. Okay, so how many different ways of that to fulfill this criteria? Okay, so in this case, okay, so we use combination. Okay, we want to calculate how many different samples of site that contains exactly 2 defective. Okay, so we can do like this. Okay, we need to count. Okay, count number of this event. Okay, I will use combination because this question did not say the order. Okay, did not mention about the order of it. Okay, so number of events, it is equals to, you see, from the combination, out of 3 defective, I must choose what? 3 choose what? Because altogether I have only 3 defective. In this case, based on the criteria, I have to choose what? From the defective, you have to choose what? 2. It must be 2. Understand? Okay. Then times. Okay. Times. Okay. So 4 times. Okay. Okay. Then how about the rest? Okay. I need 4 good ones. Okay. You must choose from 47. Which are the good ones? You choose how many? 4. Okay. Can you calculate for me? In this case, what is the number of the events that you will get from here? How many different design for this? Okay, you should get 5, 3, 5, 0, 9, 5. Okay, different ways to produce this. Okay, okay. Okay, consists of 2. Okay. Alright, so I proceed to the next one. This one I will come back to this question later when we calculate the probability later. Okay, let's move to the permutation. So a permutation is a unique sequence, okay, of a distinct items. For example, okay, so if S is equals to ABC, there are 6 permutations. Okay, it could be ABC, ACB, and so on. Okay, so I want to focus on this formula. Okay, so in this case, the formula for the permutation is this. Okay, n factorial, okay, divided by n minus r factorial only. Okay, so this is a formula for the permutation. Again, okay, so you no need to memorize the formula because your calculator should have this function already. Okay, so permutation. For example, you can do some exercise. So are you able to get 7, choose 3 from permutation using your calculator? Okay, it should give you 210. Okay, 210. Okay, so if by using Excel, we use this function, PERMUT, and choose R, you should get the same answer. Okay, so this is permutation. Okay, permutation. Alright, so let's see now. Okay, how to apply it. Okay, how to apply it. Let's see this example. The same example. Okay, let's assume that in this case, the order is important. How should we get the answer from here? So in this case, again, we have 8 different location and we can have okay, so in this case 4, okay, 4 different components to be placed on board. How many design are possible? So in this case, let us assume that the order is important. It should give you, okay, it should highlight it in the question if it is permutation. For example, if this question, okay, they mentioned that the order is important, means that we have to use permutation. In this case, okay, is 8 choose 4. Okay, by using the formula is 8 factorial divided by n minus r. Okay, so it's equals to 4 factorial. Okay, again, use your calculator, you should get 1680. Okay, so far combination and permutation is okay. Alright. So let's move to, okay, there are some certain cases. Okay, you are asked to counting similar item permutation. What is that for? It is used for counting the sequence when not all the items are different. Okay, so all these n1, n2, n3, okay, until nr are identical. If that is the case, we have to apply this formula. Okay, no r, just n. Okay, n factorial divided by n1 factorial divided by n2 factorial and so on. Okay, so in what situation we have to use this? For example, it is applied to this. Okay, so in this machine shop's schedule, okay, a piece of sheet metal needs two identical diameter. Okay, so there are two different holes drilled and two identical size notched out. Okay, the drilling operation is denoted as D and notching as N. Okay, identical parameter. Okay, how many sequences are there? Okay, so in this case we have to apply n factorial divided by n1 factorial divided by n2 factorial, because we have only two identical sides of it. Okay, so in this case, okay, so altogether we have 4, okay, because we have n1 and n2. Okay, so 4 factorial divided by 2 factorial divided by 2 factorial. Okay, hence we will get the answer which is equals to 6. What is 6 mean? Okay, you see and imagine. Okay, we have two identical diameter denotes as D. Another two denotes as N. Okay, so what is the sets of the sequence? It can arrange like this: DD and N, DN, DN, DN and D, and DDN, and D and D and DD. So that is the meaning. 6 different identical sequence. Okay, 6 different identical sequence. Okay, so that is the meaning. Okay, so let's see another example. How about this barcode? Okay, so a part is labeled with 4 thick lines, 4 different lines. Have you seen the barcode, like, okay, different thickness? Okay, it could be medium, it can be very light. Okay, so different, okay, different thickness, right? So now we have, from this question, we know that we have 4 thick lines, 3 medium lines, and also 2 thin lines. Okay, each sequence is a different labels. Of course, barcode C depends on how is the arrangement. So in this case, how many unique label can be created from this combination? Okay, so in this case, is all together, you see we have 4, 3, and 2. Okay, means that all together is 9. Okay, 9 factorial. Okay, then we have 4 factorial, 3 factorial, and then 2 factorial. Okay, at the end, you should get the answer 1260. You see? Okay, you can get 1260 different unique label be created from this combination. Okay, understand? Because in this case, they consider the sequence. 1260 barcode can be created from these 9 different lines. Okay, so that is the meanings. Okay, so in Excel we can do that. Okay, if you want to check our answer, we should write in this form. Okay, I write the answer first. 1260 is equals to, follow the formula. Okay, in the Excel we have to use factorial 9. Okay, divided by, okay, factorial 4, okay, times, in Excel, okay, factorial 3 times factorial 2. Okay, so this is how you can validate your answer. Okay. Okay, so then only we talk about the probability. Okay, so now we can calculate the probability by using this equation. Okay, so in order to calculate the probability, we have to use this formula. Okay, the number of the events. Remember how to count the number of events? It can be combination of permutation. Okay, so in this case, the probability of certain events, it is equals to the number of events divided by the number of sample space. Okay, so this is the formula to calculate the probability. Okay, so now by using this formula, let's all go back to this example again. Okay, remember this example. This is the random experiment. Okay, from the sample space we have 1, 2, 3, 4, 5, 6. Okay, let's say for these events, I want to pick the value, okay, the number which is odd number only. In this case, the events in this case, it is equals to 1, 3, 5 only. Okay, so the number of events in this case, it is equals to the number of events in this case, it is 3, right not? Okay, so now if I want to calculate the probability to obtain the number which is odd, so based on this, I can calculate the probability as back to the equation, number of events divided by the number of the sample space, which is 3 divided by 6. Why? Because the number from here, number of sample space, it is equals to 6. Hence, the probability to get the odd number, it is equals to 1/2, or we say that it is 50%. Okay? That is how we can calculate the probability. Understand? Okay, can? Alright, so now, okay, again, there are few characteristic of the probability. You see, the probability of the sample size must be equals to 1. The probability of the events must be between 0 to 1. Okay, so now let's us go back this example. Okay, remember this example? Now, if I ask you to find the probability, just now we calculate the number of the events. Back to this example. Okay. Now, how should I calculate the probability of this event? Let's say I need to calculate the probability of what is the events means. What is the probability that, okay, whenever you, okay, out of this sample size of 6, okay, contain exactly 2 defects. What is the probability? Okay, so in this case, we have to use number of events divided by the number of the sample space. Okay, number of the events, we know that we have to use C 3 choose 2 times C 47 choose 4. Then divided by what? C number of sample space. The question here is here. How to calculate the number of the sample space in this case? Number of sample space. You need to count the number of sample space. $50 choose 6. Why 6? Because every time we will pick 6 sample from here. Okay, we will withdraw 6 samples. Okay, so 50, why 50? Altogether we have 50. Okay, so 50 choose 6. Okay, so now by using this equation, okay, so what is the probability? Okay, out of 6 you will get exactly 2 defective. Okay, the answer is 0.034. Okay, 0.0034. Okay, 0.034. Okay, the probability is very, very less, 0.034. Okay. Okay, can understand so far? Okay, so I will stop for 10 minutes, then we continue with the chapter 2B later. Okay, so okay, please take a rest. Okay, so please come back at 3:35. Okay, so I will discuss random variable and the probability distribution. So what is important for this chapter is the probability distribution. Later, I will discuss binomial distribution, okay, Poisson distribution, and normal distribution. Okay. So before that, let us have a look for this first, random variable. So what is mean by random variable? So what are variable in statistics means? Okay, a variable means that it is the attribute, okay, that to describe anything, okay, which include any person, place, things, or idea. Okay, attribute to describe anything. Okay, so the value of variable can be changed from one entity to another. That is why we call it as random variable. Okay, for example, different types of the information or data. Okay, so let us have a look for this simple example. Okay, based on this table, okay, we have 1, 2, 3, 4. Okay, five different category. Okay, so they group it by student, okay, name, okay, height, weight, okay, marital status, okay, or number of cats, right? So these are all called the attribute. Why? Remember, attribute is something to describe anything. Okay, it could be person name, it could be a person height, weight, numbers of cats, etc. Okay, so but for all this category, okay, it can be changed, correct not? Okay, this value can be changed. Hence, okay, this value can be changed. Okay, so in this case, we call this as random variable. Okay, we call this as random variable. Okay, let's go through this. Okay, so a random variable is a set of possible value from a random experiment. Okay, back to the discussion just now. Okay, when you flipping a coin, we know that the number of sample, it is equals to head or tail, right? Okay, so this head or tail is random variable. Okay, or it can denote by possible value 0 and 1. Okay, you can use 0 to represent head, you can use 1 to represent the tail, or the other way round. Okay, so that is the sets of the value is called as random variable. Okay, that is the meaning. Alright, let us go through this. Random variable can either be discrete or continuous. Okay, so what is meant by discrete data? The data can only take certain value. For example, 1, 2, 3, 4, 5. Okay, discrete value. Okay, however, continuous data can take any value within a range. Okay, such as a person height. Okay, we can say that a person height average is from 150 to 180 cm, for example. So one of the student, you may get the measurements as 175.3. Any value, okay, any value within a range, it is called as continuous data. Alright, there are two types. Random variable, discrete, either discrete or continuous. Okay, again, discrete data, the example, the number of students. Why? Because I cannot say that, we have 31.5 students. Okay, we cannot say that we have 31.2 students. Okay, so discrete, we can't have half of the student. Okay, for example, the result, when we throw a dice. Okay, so the value only can have 2, 3, 4, 5, 6. Okay, I cannot have the result 2.2 like this. Okay, cannot be. Okay, so this random variable is called as discrete. Okay, how about continuous? Again, what I mentioned just now, it could be a person height. Okay, any value within a range. Okay, time. Okay, weight, length, and a lot more. Okay, so this is the example for the continuous random variable. Okay, then of course, by definition, a random variable is a function that assigns a real number with each element in the sample space. Okay, random variable can be discrete and continuous. Discrete random variable is a random variable with finite range. Okay, so continuous is a random variable within an interval. Okay, so that is the meaning. For example, electrical current, length, pressure, temperature, time, voltage, and so on. Alright? Okay, understand? Random variable, we have two types, discrete and continuous. Okay, again, look at this. Okay, random variable, we can denote it as R dot B, random variable. Okay, so normally we present it by an uppercase of X. Okay, we represent this as random variable. Okay, it can be discrete, it can be continuous. Okay, each value of random variable, we call this as probability. Okay, probability can be calculated using this value, this formula, number of the events divided by the number of samples that I have just discussed with you. Okay, if we could list down all possible values of random variable, we call this as distribution. Okay, do you remember there is one question mentioned about frequency distribution? Okay, so if we could list down all the possible value of random variable, that is called as probability distribution. Okay, so I will discuss the probability distribution later. Okay, right, so let us have a look. Okay, what is meant by probability distribution now? Okay, just now we have introduced probability is a value. Okay, now let us have a look. Probability distribution. Okay, the probability distribution of random variable X is a description of all the probabilities associated with all possible value of X. Okay, again, so you might not understand this part yet. Okay, I will go back to this later. Okay, so discrete probability distribution, it is called as probability mass function. Okay, I will further discuss this part next week when I talk about the binomial, normal, and the Poisson distribution. Okay, there are two types: discrete, continuous. Its probability distribution it called as, for the discrete we call this as probability mass function. For the continuous we call this as probability density function. Okay. Okay, back to this example. Okay. So we want to develop the probability distribution. Okay, probability distribution, for example. Okay, so for this experiment, okay, let's X be a discrete random variable. Okay, so X is indicate the number of 4 that you obtain when 2 dice are thrown. Okay, so what are the possible value of X? Okay. Okay, so what are the possible value of X? Okay, how many times you see, you imagine, okay, now you're performing this experiment. Okay, we have 2 dice. Okay, every time, okay, we throw this. Okay, so what is the possible, okay, how many times the number 4 will be appeared? Do you understand? We have 2 dice. Okay, now you perform this experiment. Okay, what is the possible outcome? Okay, the 4 will be appeared. How many times? It could be, when you throw this, none of it be 4, correct not? Hence, that is why it is 0. Understand? It could be, okay, one's other's value, but 1 consists of 4. Okay, so this is 1. Understand? It could be both appears as 4, so 2. Understand? Can you understand? Can understand why it's 0, 1, 2 or not? Can? How many times number 4 will be appeared in this case? Okay, can? So the only possible value for X is just only 0, 1, 2. Can it be 4? Cannot be, okay? We only have 2 dice, okay? Cannot be, right? So the only possible 0, 1, 2 only. Okay? Let us distribute, okay? Let us develop the probability distribution now. Okay? So in this case, we write down the possible value of random variable. In this case, it could be 0, 1, 2. Okay? 0, 1, 2. Okay? 0, 1, 2. Okay, now we need to calculate. What does this mean? Calculate what is the probability when X is equals to what? Okay, that is this mean. So what does this mean? I need to calculate what is the probability that none of it be 4. No 4. No number 4. Okay? Then I need to calculate the probability. Okay? I have 1, 4. Okay? What is the probability I get 2, 4? What do you think? Which has the highest probability? What is the chances to get this? What do you think? Very, very less, right? Okay? Okay. So how to distribute this? If I give you a solution like this. Okay, look at this. Okay, it is easier for you to understand through this. Okay, so we have this 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Every time, okay, because every time we throw 2. Okay, so now I want number 4. You see, okay. 2 times of 4. Okay, I pick up all the 4. Okay, so this one have 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4, 1, 4. Okay, so this one have 1, 4, and 1, 4. Right? Okay, so and then I notice that that is 1. I get both number 4. Okay, based on this table, are you able to calculate the probabilities? What is meant by probabilities? Number of events divided by the number of sample. Okay, if you look at this, all together, how many possible design? We have 6 times 6. We have 36, right? So altogether, okay, we have by formula, we know that this one is 36 divided by 36. Okay, so what is, okay, how many times you can get 1 based on this? Only 1 time. Okay, so how to calculate its probability? So in this case, okay, in this case, the probability is 1 over 36. Understand? Okay, so how many times you can get 1 4? Okay, 1 2 3 4 5 6 7 8 9 10. 10 times, right? Now, consists of 4, number 4, right? Now, hence the probability is 10 divided by 36. Can understand? Okay, so 10 divided by 36. Okay, how many times you can't get any value of any number of 4? How many times? So your minus 36 minus 10 minus 1 is equals to 25. Hence, 25 divided by 36. Okay, now, okay, if you are able to show this table, okay, list down all the possible value, okay, of the random variable, and then you will figure out when you sum up this value, it must give you 1. Correct? Okay, this is called probability distribution. Understand? You list down the probability for all the random variable. This is called probability distribution. So if you want to plot it in the histogram, it could be like this. Okay, histogram. Okay, so this is the probability distribution. This is the random value of x. Okay, in this case, it could be, it should be like this. Okay, so this is x when x is equals to 0, 1, and 2. So this is cos 25 over 36. Okay, so this is 1 over 6, 1 over 36, 10 over 36, and then this is 1 over 36. Okay, so this is called probability distribution. Okay, can be plotted using histogram. Can understand? Okay, so this is called probability distribution. Okay, remember, if you can get some of the probability, it must give you 1. Okay, then only it's called as probability distribution. Okay. Okay, can understand? Okay, so let us go through another example. Okay, so now, okay, give you some time to read about this question. Okay, so in this case, they are, okay, so about the, okay, that is a bit transmitted through a digital transmission channel. Okay, so the possible value for x are 0, 1, 2, 3, 4. Okay, based on the model, okay, for the error that is presented in this section, the probability of this value will be determined. Okay, suppose all these probability are given as such. Okay, they tell you already. Okay, so we have this. The probability x is equals to 0 means what? In this case, they said that, okay, we need to count how many possible error. X equals to 0 means what? X equals to 0 means what? There is no error. Okay, so that the probability is given as such. Okay, X is equals to 1, 2, 3, 4, and so on. Okay, in this case, okay, we can plot the graph like this. Okay, like what I have mentioned. Okay, so you can plot in the histogram like this. So this is indicate the number, okay, the random variable. It could be 0, 1, 2, 3, 4, and then this is the corresponding probability. Okay, so based on the value, you can plot like this. What you will observe here is when you sum up this value, it should give you 1. Okay, it should give you 1. Okay, so this is called as probability distribution. Okay, Ken? Any question? Okay, no question, eh? Okay, so there are few slides talking about the probability mass function. Okay, I will not going to explain this first. Okay, so I will come back this later when I discuss the binomial and the Poisson distribution. Okay, probability mass function. Okay, actually probability mass function, okay, is a frequency function for a discrete random variable. That's all. Okay, if you look at the it can be plotted by using the histogram. Can you see here? Okay, a histogram can be used to tabulate the probability mass function. For example, this is the score. We know that 10% score between 20 to 30 marks. Okay, so it's very clear. Okay, so it is discrete variable from here. All right. So of course it has some characteristic. Okay, for example, okay, a probability mass function, the probability must be equals, okay, must be more than or equals to 0. The summation of all the probabilities, it must be equals to 1. Okay, I will come back to this later. All right. Of course, cumulative belongs to the continuous. Okay. So what I will discuss here, means and variance. Okay, I will not talk about this first. Okay. Let us go through this. Okay. Random variable, because some of the notes I will discuss during the tutorial. Okay. So let us go to this slide. I will cover one section which is called as binomial. Okay, because you just learned combination. Okay, so this is very related. Okay, so again, random variable just now, okay, we know that it is discrete and continuous. Okay, so for the probability distribution, we use probability mass function. Okay, so under this, okay, we could have a special probability distribution. Okay, it is the same for the continuous. Let us go through this one by one. Okay, so now discrete random variable, in the special probability distribution, we can have, for example, binomial, geometric, hypergeometric, and Poisson. However, in this case, we will just focus on these two, binomial and Poisson. I will not cover the other two. Okay, this is what you have learned. Okay, for those who attended the engineering mathematics. Okay, I already covered this. Okay, so binomial distribution, that is why I will discuss this part first. Okay, let's see. Binomial distribution is the random variable x that equals the numbers of trials that result in a success is a binomial random variable with parameters between 0 to 1, and n could be any value. What does this mean? Okay, never mind. Okay, let's see. Okay, a random experiment consists of n binomial trials such that the trial is independent. Okay, each trial is only 2 possible outcomes. It is labeled as success or either failure. 2 only possible outcomes. That is why it is called bi. 2 possible outcomes only. It could be presented success, failure, 0, 1, okay, true or false, like this. Okay, only 2 possible outcomes. Okay, so binomial distribution, okay, for example, we can use this formula to find out the binomial distribution. Okay, so in this case, Px is equals to x. What is the meaning of this x? Capital letter X is indicate. Capital letter X is indicate random variable. Okay, is equals to x. What is the x means here? X can be any value, 0, 1, 2, 3, 4, 5, 6, etc. Okay, then is equals to, what is this symbol means? What is a symbol mean? Combination, okay, you have just learned it, okay, combination, okay, and choose, okay, in this case they use x, and choose x, okay, times times p, okay, power of x. P in this case means what? Probability, okay, and then times 1 minus p, power of n minus n. So this is the formula for the binomial distribution, all right. In this case, I will, of course, this one we have just understand the binomial, how to calculate the binomial. I will not touch this. Let us have a look for this. Okay, I will use one example. Okay, okay, binomial distribution. Let us use this example. Okay, a study shows that the color blindness affect 8% of men. Okay, in this case, if you look at this example, what is the information that we have here? They tell you what? What is 8%? 8% is means what? The probability. Okay, in this case, P is equals to 8%. 8% means that 0.08. Okay, then a sample of 10 means what? N is equals to 10. N is equals to 10. Okay, so now by using this information, you are required to find out the probability. Okay, so for this criteria, so we have all 10 men are colorblind, no men are colorblind, exactly 2, at least 2, by using this formula. Okay, by using this formula, let's figure out one by one. Okay, we start with A. All 10 men are colorblind. Okay, in this case, what does this mean? Okay, for example, in this figure, we have 10 men only. Okay, from the study, we already know that the probability of the men, okay, colorblind is only 8%, 0.08. Okay, now what is the probability of all 10 men are colorblind? You must know that the probability is very, very less. Why? You see here, okay, if by looking for this diagram, it is indicates, okay, we have 10. So every single 0.08, okay, power of 10. You can get the probability which is equals to 1.07 times 10 to the power of negative 11. Okay, if we substitute into the equation, look at this, substitute into the equation, it is indicates yx is equals to 10 because they want 10 men who are colorblind. So x is equals to 10. Okay, understand? Okay, so it's equals to, follow the equation, okay, C 10 choose 10. Okay, then P, okay, P is what? 0.08. P man, power of x, okay, so is 10 times, okay, 1 minus P, so 1 minus 0.08, okay, power of, okay, this is n minus n. Hence, okay, you will get the same answer. Understand? That is the meanings. You just left 0.08 power of 10. Okay, this is by using formula. Okay, this is by using formula. Okay, how about the next section? Okay, what is the probability that no men are colorblind? If we change to the mathematical equation, it is indicates no men. So x equals to 0. No. Okay, no men are colorblind. Okay, so in this diagram, of course, no men. Why 0.92? Because 1 minus 0.08. Okay, so all are good one. Okay, so 0.92 power of 10, you get 0.4344. Okay, if by using the formula, it is written in this form, x is equals to 0 is equals to 10 choose 0. Okay, then P 0.08, okay, power of x is 0, okay, times 1 minus 0.08, okay, power of 10 minus 0, okay. That is why you have 0.92 power of 10, hence you get 0.4344. Okay. Alright, so in this case, let us go to C. How about in this case, what is the probability that exactly two men are colorblind? In this case, P, x is equals to 2. Okay, x is equals to 2. Okay, let us substitute in the formula. So x is equals to 2, I already have here. Okay, what is the answer that you will get from here? Can you calculate the value? You will get the answer which is equals to 0.147807. Okay? Okay, I will change this change to Excel. Okay, I will further explain the binomial distribution through the Excel, right? Okay, so for this example, okay, okay, see here, okay, I already defined the x, okay, all the possible of the random variable. Why it is 0, okay, to 10? Because we have 10 men, okay, so 0 to 1. Okay, in this case, I need to calculate, okay, the probability for each value of x. Okay, so in this case, what you need to do is equals to, look at this, equals to binom, okay? Because we know that this is binom distribution, D-I-S-T, okay? When you key in this, okay, so let us look at the description first. Number of success, trial, probability as cumulative, okay? You need to key in this information, okay? So the first one, number of number of success. Okay, number of success. What is the information you need to key in here? Okay, so it is, sorry, I will key in, highlight this before, so I no need to key in one by one. Okay, then the second information, okay, trial, I have 10 times. Okay, probability of success, it is mentioned, it is 0.08. Okay, 0.08. Okay, in this case, you need to key in another things, which is, if you look at this carefully, we need to key in true or false. What is meant by true here? cumulative distribution function. Okay, force probability mass function. Do remember, okay, binomial is discrete. Hence, in this case, we use force because we need to calculate in this objective. Okay, we need to calculate the probability for each value of x. Okay, so we use force. Okay, in this case, click enter. Okay, we are able to get the probability already. Then, okay, we track this to the end. Okay, we should get all the answer. Okay, to check our answer just now from the part A, you are required to calculate when x is equals to 10. So this is the answer. For question B, you need to find, okay, when x is equals to 0. So this is the answer. From part C, you need to count exactly 2 equals to when x is equals to 2. Hence, this is the answer. Okay, this is how you can check your answer. At the end, you will figure out that, okay, the summation of this probability, okay, let's check, okay, try to add this value, it must return 1. So what is the conclusion here? This is called probability distribution. So when you want to plot this graph, you can, okay, so you insert the diagram, histogram. So this is the probability distribution already. Can you see? Okay, so x-axis indicates the random variable, p indicates the probability. So you have all the answer with you already. Okay, can? Okay, so this is called probability distribution. Is that okay? Can? Okay, so following from this, you have one question. Okay, if you look at part D, okay, so I will explain here. You need to calculate when the x, okay, which is greater or equals to 2. What does that mean? The x, okay, if by, okay, looking for this equation, so we need to find out what? From 2 to, that is the meanings, right? When x, okay, is more than or equals to 2, okay, means that, okay, you see, okay, we have to add this value together. Okay, this is the first method. You get all the value and then you sum up together. Okay, so this is the answer that you can get 0.188. Okay, the other, okay, this is you need to find out all this value. Okay, the simple way you can do what? You can use 1 minus what? Minus, okay, you know that it is equals to 1 minus this 2, right? Why not? Okay, so this is, you still can get the same answer. Okay, in Excel, okay, what should you do? Okay, we can key in equals to, okay, look at this, 1 minus, okay, binom, okay, again, dot dist, okay, so I need to key in this, okay, so this one I need to key in, okay, 1 minus what? 1 minus, okay, includes 0 and 1, so I key in 1, okay, so this one 10, okay, again, this is 0.08. Now, in this case, cumulative, I need to key in true already because I asked the Excel to add 0 and 1 to me. Okay, so if you key in this, you should get the same answer. Okay? Alright, that is how you calculate the probability which is more than or equals to 2. Okay? Understand? Okay? You can try to use Excel to check your answer. Okay? Alright, okay, so back to the discussion. That is why this graph can be plotted. This is called probability distribution. Okay, so when you add all this value, must equals to 1. Okay, how this value can be obtained to the formula. Okay, through the formula. Okay, understand? This is called probability distribution, binomial probability distribution. All right. So again, this one I give you the answer already. Okay, when we need to find x more than or equals to 2, okay, better we use 1 minus. Okay, 1 minus sum of these two values, you get 0.188, right? So again, okay, so using Excel, okay, again, this is the function. What is force? What is force? Anyone remember? There are two types, either true or false. What is force mean? Probability mass function. What is meant by probability mass function? We just only want to know the probability at particular value, discrete. Okay? If true means that you accumulate the value together, 0 to 1, okay? 0 to 2, etc. Okay? Understand? Okay? That is why in sometimes you need to use true, sometimes you need to use false. Okay. I still have 2 slides. Let's continue for this. Okay, so studies show the color blindness affect about 8%. So using the same example, what is the expected number, okay, of the color blind in the example, in the sample, and the standard deviation? All right, so let's see. So for the binomial distribution, okay, the expected value means the mean, okay, is calculated using NP. Expected value. Mean, okay, the meanings here is mean. Okay, n times p. Okay, we have n is 10, p is 0.08, hence is 0.8. Okay, so this formula is for binomial distribution. Okay, so expected value. How about the standard deviation? Okay, standard deviation, we can calculate it through this formula. Okay, the first one, the variance first. Okay, the variance, the formula is NP, okay, 1 minus P, or sometimes you will see that the formula give you is NPQ. Okay, it is the same. Okay, N, okay, number of the sample, P, probability, okay, Q, 1 minus P. Okay, in this case, we get 10 times 0.08 times 0.92. Hence, you get variance is equals to 0.736. Okay, this is variance for the binomial distribution. Okay, so hence, for the standard deviation, square root it, we get the standard deviation. Alright, so this is the discussion for the binomial distribution. What you have learned today? You learn probability. Okay, just remember probability, the formula. Okay, is NS divided by, NE divided by NS. Okay, you must understand that. Okay, you have learned about random variable. We have 2 types, discrete and continuous, and then one type. Okay, one of the types of the discrete probability distribution is binomial. That's it. Okay, just remember what you have learned. I will further discuss this, okay, next week for your tutorial. Okay, if not too many for you for today already. Okay, I think I will end the section now. Okay, so is that okay? Okay, alright, so that's all for today.